As a quick disclaimer, if you are an engineer of the software, electrical, mechanical, or networking variety, this video is probably going to make your ass hurt, your balls explode, or both. That being said, there's a lot of people out there that are probably going to be a lot better at the respective jobs that I'm doing in this video than I am. So please, if I do something incorrectly, make a video critiquing, but helping me out in a way that I can actually improve the system that I've created rather than you getting me to kill myself, because getting me to kill myself is bad.
Gosh, so I don't think I've ever seen such a goofy statistic in my entire life, but here we are. Less than 1% of you are subscribed. Please subscribe if you like my content. You'll get like notifications and stuff, and that's pretty cool. And I think I post pretty good stuff, you know? Wouldn't you agree? Yeah, hit that subscribe button. Maybe we can get to 1% one day. Let's go.
I also want to say that I will not be making this project public like my previous one. This is not a very easy or user-friendly project to set up to use for yourself. This can also introduce some network vulnerabilities if you misconfigure it, and that I will not be responsible for. Think of this video as kind of an explanation on how I was able to do this and figure it out, rather than a tutorial on how to recreate this yourself. That being said, if you are able to recreate this yourself, that probably means that you actually have some semblance to know what you're doing to be able to recreate it, so all the power to you, I guess. Anyway, let's get started. So, my friends and I like to play video games together, and one of those video games that we like to play is Minecraft. And obviously, Minecraft is not a game that you can kind of throw yourself into a lobby like Call of Duty. You need to have a dedicated server for you and your friends to play on. Now, you can play on a public server, something like Mineplex or the Hive, or if you want to have your private server, you kind of need to set that up yourself. Now, having your server be on the computer that you play Minecraft on can actually take up a lot of resources. So that's why I actually have my server hosted on this Dell Optiplex. I believe I have made a video about this thing before. Don't watch it, it's ass. The video I mean, not the computer. The computer is actually great and is honestly a really, really good server for what I want to use it for. Done vanilla games on it, modded games, even huge mod packs that you would find on something like CurseForge, and it's been great. The only thing is that I don't like having this computer on 24/7. This computer is already pretty old, and I want to be able to extend the life of it as much as humanly possible. So pretty much whenever it's inactive for long periods of time, I like to turn the server off. That being said, if any of my friends want to play on the server, they usually have to message me and tell me to turn the server on, but once again, I can only do this if I'm home. If I'm not home, I can't press the power button like that and turn the computer on, because I don't know, I feel like if you're like on this plane of existence, you can understand why I can't press the button when I'm not here. I'm not going to go over the details on how to create your own Minecraft server. There's probably hundreds, if not thousands, of tutorials out there to show you how to do that. But if you want some of the details on how I set up my server, then here you go. So my server is currently port forwarded, which basically means that I have to give my friends my public IP address so they can connect to the server through Minecraft. This isn't a big deal. The only thing is I would recommend using a whitelist, as anybody who has your public IP address can join your server. This also means that you should really only allow people that you trust on your server, because someone with malicious intent can't do a whole lot on the Minecraft server port, but they can use your IP address to pretty much find your location. So anyway, so basically the reason for this whole video is I wanted to create a system where my friends can effectively run a program that would turn the computer on and also the server on with a really simple click. So to alleviate the issue of the server being off when I'm not home, I wanted to create a system that my friends could use to turn the computer and the Minecraft server on whenever they wanted to play. Step one of this whole situation is I needed to figure out how I could trigger the power button to turn the computer on without using the physical power button. And thankfully, this is pretty simple, because let's be real, if it wasn't simple, I would probably have to go back to my university and return my degree. To do this, we're going to need two different components. The first and the most important one is this. This is a Raspberry Pi. If you're not familiar on what this is, it's pretty simple. All it is it's a tiny computer that runs Linux. Probably the more important part is there's pins inside of here, I'm not sure if you can see that, where you can actually hook up multiple electrical components and get them to run off of those pins. If you're familiar with how an Arduino works, it's pretty much the exact same way. So what we're going to be doing is we're going to be hooking up the power button pins. If you're familiar with PC building, you know exactly what I'm talking about. And if you're not, don't worry, I'll elaborate in just a little bit, directly to the Raspberry Pi, so the Raspberry Pi can send a signal and turn the computer on. So like I was saying, if you're familiar with PC building, then you know exactly what I'm talking about. But if you're not, here's a pretty quick explanation. On pretty much every computer, the power button is connected to effectively two little pieces of metal, a wire going from both of them to the power button. When you press the power button, what you're effectively doing is you're shorting the signal between these two wires. You're effectively connecting them. And this shorts the signal and allows the computer to turn on. We can't use the Raspberry Pi all by itself, or at least I don't think you can use the Raspberry Pi all by itself. What I did is I went on Amazon and bought a bunch of these. This is called a relay. Relays are pretty simple, but it's going to be easier to understand if I have a close-up or diagram to explain it to you. So yeah, here's that now.
All right, so here we have a close-up image of the relay that I'm using. It's not the greatest picture, but it's honestly good enough. The relay is pretty simple. On the right-hand side, we have the input. The top contact is the 3 to 5 volt trigger, and this is what activates the relay. Then we have the ground, and then we have the 5 volt DC in, which powers the relay. On the left side, and this is where the action happens, very exciting stuff, the top contact is the normally open terminal. Then we have the common terminal, and finally we have the normally closed terminal. I built a small circuit which kind of shows how a relay works. Here it is. All right, so a crappy video of a relay followed by a crappy photo of one. Let's go. So we can see that we actually have all of our terminals already hooked up. Over on the right hand side, you can see that our positive and negative terminals are connected to the 5 volt in as well as the ground on the breadboard. We can then see over on the left hand side that we have the common connection hooked up to the 5 volt in on the breadboard. We're effectively taking power in from that positive connection. We can see that our normally closed connection, which is currentently connected to that common wire, is hooked up to the positive terminal on the red LED, which is why it's currently powered. And our normally open connection is actually connected to our blue LED. Now watch what happens when I connect the trigger to our 5 volt in, effectively giving it a 5 volt signal to trigger the relay. We can see that the red LED, which was originally normally closed, is now open, causing it to turn off. And the blue LED, which was normally open, is now closed, allowing it to turn on. So what happened is originally the normally closed terminal was connected to the common, which allowed the red LED to receive power, and the blue LED, which was connected to the normally open terminal, was not connected to the common. And when you hit the relay, or when you send a signal on the relay, it effectively switches the normal attribute of each of these LEDs. So we can actually see that our blue LED is actually how we're going to be turning the computer on.
Now, because this little circuit is really, really simple, we actually don't even need to use a breadboard at all. A breadboard would probably make it look cleaner, but it's not actually necessary to get everything to work correctly. But anyway, here's what everything looks like hooked up. Okay, so this is where I'm gonna make the networking engineers cry. So we have the circuit set up, and when we run a script from the Raspberry Pi, we can send a signal to the relay, and the relay will close the circuit between the power button pins, which will turn the computer on. Now what we need to do is figure out a solution on how my friends from their house can run a command or a script or a program that will run the program on my Raspberry Pi to turn the computer on. So because I'm not exactly sure how safe or how vulnerable this makes your system, this is going to be the whole part of the project that I'm going to be glossing over going forward. So I'll give you the general idea of what I did and how I did it, but I'm not going to show you exactly what I did, the code, or anything like that. So before we get into anything, you need to know what an SSH is. Now, I already use an SSH server on my Minecraft server, so I can actually access my Minecraft server remotely and run commands and control the computer while it's already on. What SSHing allows you to do is it allows you to securely connect to another computer and control it through its terminal. This will allow you to run commands from one computer and have them execute on another computer. However, we need to make this SSHing system public. Now, this is dangerous because by doing this, we're effectively opening up the SSH port to everybody on the internet, which means as long as they know what my IP address is, or even if they're using a brute force attack, they can connect to my SSH server, log in, and effectively take control of my entire computer, both the Raspberry Pi Pi and my Minecraft server. So to hopefully alleviate this, I set my SSH server on my Raspberry Pi, which is going to be the SSH server that will be accessed remotely, to, I wish I were making this up, it's called paranoid mode. If you're familiar with whitelists, even through Minecraft, wow, look at that, it comes full circle. It allows you to create a list of IP addresses that are given privilege to access the SSH server on whatever computer you're using, or in this case, my Raspberry Pi. So basically, if any of my friends want to use the system that I've created, I have to ask them for their public IP addresses. So when they use the program to SSH over to the Raspberry Pi looks at their IP address, says, yep, they're allowed in, and lets them in. Also, as a second security measure, I have put a fairly complicated password on the SSH server itself. So for example, if you happen to go to the house of the person who already has privilege to have access to the Raspberry Pi, you can't simply just log in. You need to know the password as well. So two-step verification. Now that we have the general basis on how this whole entire program is going to work, we need to write some code. And effectively, this code needs to do a couple things. First, we need to access the Raspberry Pi from whoever's computer is trying to turn the server on. Then once we access the Pi, we have to do two things: physically turning the computer on, and then going into the Minecraft server and turning the Minecraft server on. It all sounds pretty complicated, but I was able to figure out a way to do this using only one exe file and like 4 different scripts, but we're about to get into that. Like I just said, obviously I can't have my friends typing in like 6 or 7 commands to get this entire system to work. That would be completely pointless, and it would destroy the streamlining of this entire system, and it could also make it super easy for any of my friends to mess something up, or I don't know, have them destroy something because they had access to something that they technically weren't supposed to. So like I said, I made 4 different scripts, and I'm going to go through each of them. Script number 1, which was written in Python, is actually turned into an exe file, and this is going to be the script that will be on everybody's computer that wants to have this functionality. All this script really does is it SSHs from that computer over to my Raspberry Pi, and that's where script 2 comes into play. Script 2 is also written in Python, and all script 2 really does is run script 3 and script 4. Script 3, which is written in C, is the script that is on my Raspberry Pi, and what that script does when executed is it sends a signal from the Raspberry Pi to the relay, turn the power button on, or the power button on, to turn the computer on. Script 2 then waits, give or take about a minute, because what we're doing now is we're waiting for the Minecraft server to fully boot up. From there, it then SSHs from the Raspberry Pi into the Minecraft server, and then sends a command to script 4, also written in Python, to turn the Minecraft server on. What the user will see from their side is pretty simple. It's pretty much just a terminal debug screen, and when it shuts off by itself, you know that the server is, or at least should be, on. So now you're probably wondering, does this entire system work? Is it reliable? Does this make my friends want to kill me less? And the answer to all of those is a resounding yes. This was actually way more successful than I thought it would be. I originally thought that there was going to be a lot of problems day to day. My friends would try to run the script. It seemed like it would work, and then the Minecraft server just wouldn't turn on, or the computer would turn on, but not the Minecraft server. But thankfully, I've been using this script for about 2 months now, with about 4 different friends having access to the script, and it runs really well. And it saves me a lot of time because honestly, a lot of my friends wake up much earlier than I do. So by the time I'm awake, the computer is already up and running, and they're probably already playing Minecraft on it. Also, another thing you're probably wondering is the network vulnerability portion, because once again, we are effectively opening an SSH server to the entirety of the internet. So I have been doing some pretty close monitoring day to day to see if there are any IP addresses accessing the Raspberry Pi that I do not recognize. Thankfully, the answer is no. The only IP addresses that are on the Raspberry Pi at any given time should be the IP address of someone who has the program, who's trying to turn the server on. I know that the system is not perfect, and to all the engineers watching, I'm sorry, man. You're probably shaking and crying right now, possibly having a stroke, maybe even hemorrhaging blood out of your ears, but I would ask that you slow down and ask yourself, how would I improve this situation? And then take that idea, type it into the comments, help me improve my shit, because any information that I could learn or use to make this system better would honestly be really appreciated. Because I'm just gonna say right off the bat, SSHing is definitely not the cleanest solution, but I did it because because I know how to SSH, I know Linux commands, and probably the biggest part, it's free, dude. It's free. Thank you all for watching. I hope none of you hurt yourself trying to watch this video. This project was honestly really fun and didn't actually take me that long to complete. Anyway, if you're interested in another one of my projects, here's another project that I made where I actually created a mouse move program. I don't really know how to explain it, that allows you to play Metroid Prime Hunters on the PC using a keyboard and mouse. It's a pretty cool program that understandably has a pretty niche audience for it, but I already have people in the comments saying that they are using my program to play Metroid Prime Hunters on the PC. And that program, unlike this one, is actually free to download. Once again, thank you for watching. I hope you have a wonderful rest of your day and a great 2023. Follow me on Instagram, Twitter, and Twitch. That's pretty much it.